So hello, now this is the next part of the video that I'm recording. Currently, what is the time? It is 5:55. Okay, so here what I have added is a few little stuff. This is mostly for DFS. Okay, not the ID-DFS. So it will be a short video because okay, I have done the plotting and everything. So that plotting will be discussed in the last part of this whole series. Now let's get started. Okay, so the first thing that we are going to revisit is the menu. Okay, this is something that I've added and all this. After the menu, you have these functions which are like last time we only discussed the solve BFS, and here I was having something like print and plot the path. So remember in the earlier video we actually printed a lot of the things. So what was the next step? That is basically going into processing and everything. Here it will be much more of a cleaner solution because we don't need that many print statements. That was just during the whole writing the program phase where you don't know like what will be the correct thing, what will be the wrong thing. As you can see, these things like discover new state, adding to the queue and all this, these are actually removed, and now it will print a very simple path. Okay, now this is there, and in this generate next state function you will see that there have been a few minor changes. Main change that you can see is with this thing. This is void data structure. Okay, now what was it actually before? Let's go and see. So here it was a queue. Okay, it was directly using a queue, but now because we have different data structures like queue and a stack, so the point is how we can't actually have a queue and a stack like both in different parameters, right? Like we can have, but then one will be empty and it will never be used. So that is not a good, that is something actually one can do and it's totally fine. And uh but what I wanted was like a more generalized way, which is the data structure. So the name data structure is a variable name and it is a void type of data structure. So it will be typecasted to a queue or a stack based on the need. After that, what do we have? We have a type. This will be used later. And we have a depth limit because this is for ID-DFS. Now you will see that nothing has changed except for this line. This will be explained in the next video, the ID-DFS one. Now the DFS. Okay, so let's start with the things that we need mostly. You see that here only this depth has been added because for ID-DFS. Okay, I'm not going with that. The main thing is this thing, the stack implementation, because this is required for DFS and ID-DFS. So what is a stack? Imagine it like a stack of plates, stack of books, and stack of clothes, and you basically can only take out the last cloth that you put in it. That means you have some like you have this like last in and the first out kind of data structure. In that case, you call it a stack. You have the items and the top variable. Just like in queue, we had a rear and a front variable that were noting down the position of the starting of the queue and ending of the queue. Because a stack is basically bottom is blocked, you only need to take care of the top element. So the top basically contains the last element that was put in, and it will be the first element to go out. So there is only one way of basically insertion and deletion. So that's why it's simpler. And now again, I could have gone with a more robust implementation using a linked list, but I've gone with a like more traditional way of doing it. Not traditional, like let's call it a simple way of doing it. Okay. So what we have done, we have actually created the array for it. Okay. And what we are doing, we are first initializing the top to be -1 because there is nothing there. Then we check that if the stack is empty, that is only when the top is equal to -1. And then we push items, which basically means that I need to increment the top with one value, and at that particular index, I need to add the value to that items array. After that, we just pop out the item from the items array with that top variable. Now, basically, it's the position variable, and now it need to decrement it. That is a simple implementation of the stack, but that's not the point. We are going to come to the void, plotting the states and everything very quickly. Now, next, what do we have is this one. So I think I have this add the states. We can discuss about it. Yeah, I can actually do it right now. So better I just go and show you the DFS, and then we will, when we are going to call the add states, we are going to show it to you. Another point is what? You have a visited list. Okay. Again, the same way of initialization, the visited list, instead of having a queue, we have a stack. And instead of initializing the queue, of course, we are going to initialize the stack. After that, we take the initial index, which would be a simple add state function. Now, what is this add state? Now, here we come over to this add state function. Now, in this, we have a x and a y variable. We have a parent index, and then we have an action, and we have a depth. Okay. Now, understand that this depth is only for ID-DFS. Okay. Otherwise, the depth won't matter much to us. Now, if you remember quite clearly, there was another function. Yeah, all states. Where is the, oh no, all states was just a variable. Where is it? Oh yeah, generate next states. This function will be totally common to every other function, so you don't need to worry. Now the point is what actually happens in here. It just simply adds the state to the all states. Okay. Instead of having this line where you used to add the states to the all state, you create a function that does it for you. It abstracts away the adding implementation. How it does that? First, it checks that the current state count, is it greater than or equal to the max state? That means we have already exited or exited. Nahi. क्या कहते हैं उसको? Exceeded. Yeah, we have already exceeded the maximum possible states that we could actually accommodate. Then what do? We simply do the assignment. Now, remember in the last video, we were actually having all this assignment line done inside the algorithm. Now, basically, you abstract away into a function. Now you have this. This is a state variable. Sorry, a state variable, state type casting of this array. Now, this array, again, X is the amount of water in the 3-liter jug. Y is the amount of water in the 4-liter jug. You have the parent index. The starting will be -1. Action that needs to be performed, and the depth of the DFS path. After that, you basically increase the state count because you have added one more state. Now, after that is clear, let's go back to the DFS. So you basically take the initial index as you add the state 0, 0 with no parent. This is called the initial state, and of course, the depth needs to be 0. That means you have already visited this particular configuration where it is 0, 0. Then what do? You push the element. Remember, we used to do an NQ operation here. In DFS, because it is a stack, we do a push operation. After doing the push, we will check that, okay, is the stack is empty? The, of course, answer is no, the stack is not empty. And then we basically print out the, print out kabalo, and then we basically pop out the last thing that is already there and put it in our current index, because that is like a to-do list. Whatever is left inside the list, I need to do it. Now, from the bag of, let's say, a basket, I just take out the first item, which is my current index, the current job that I need to do. Because this is the current job that I need to do, I basically go to the all states and with the current index, and from there I retrieve it and I put it into the current variable. This current variable is of the data type state, which is a user-defined data type, which contains the state information of the current state. Now, this is the corrected goal check. This is because, okay, so while I was doing this, I need to be honest, I messed this particular up because, see, I was thinking like, okay, this goal check was basically not y but x, and then I was getting like the answer not to be correct, and then I asked AI to basically help me out what is wrong, and I was like, found that, oh damn, I was just so stupid that I missed out that what would be the correct correct checking. So basically in the question, if you just go here, so what was it? Yeah, so here it is. The goal state is 0, 2, but I basically thought that it was not that. So yeah, sorry. Yeah, that's where I used AI. I have to be careful, but it's a very stupid mistake. If I was not impatient enough to submit it by today, I probably would have gone into it probably, I don't know. Now after this, basically you call the generate states with the stack data structure. See here, I am passing the stack itself. Okay. Now if you go to the generate the next states, you pass the stack data structure, because you do a for like basically the pointer type, and after that you do all the assignment just like you used to do before. Now here you need to check that there is a new depth, which is the current depth plus 1. So the thing is that for ID-DFS, don't generate states beyond the depth limit. This is the main checking point. But suppose this is, see the depth limit, if you remember in the function, this is the depth limit, which is the last parameter. Now if you go back to the DFS function, remember that what's the depth that we actually gave? It is given at the depth of sorry, that is 0. What? Oh no, sorry, this is the add state. Yeah, this is the -1. So -1 of depth basically inactivates the depth function. Okay, why? See this, if that is not equal to -1, that means it is currently is equal to -1, so this function won't be used. That's good. After that, everything remains totally the same, so you do not need to worry about anything. Okay, and yeah, that's how just you implement. Oh, by the way, understand that, okay, I need to say this once. If the type is q, then you do an enqueue operation. Okay, else you do a push operation. So this small minor change lets me use this if block without creating this whole function again, just for a stack implementation. That means just for a DFS implementation. Let's just do the compilation of, I call it main. So yeah, let's do that main, and I'm doing the depth first search. Yes, there is this fcint warning, which is a font config warning, and I was reading the, like, what they call this, libraries for it. I currently don't know why this warning is coming. This is probably related mostly to the GNU plot, because each of these warnings that you're seeing was not coming when I was not using the GNU plot. So whatever. Now the point is, yes, this is the solution gift that has been created. So you can see the DFS right there in action. Okay. And yeah, okay. Yeah, so this is actually depreciated. I need to check. Sometimes I use magics. So I remember, yeah, this is what the command I use for conversion. It's a very nifty tool, because see, in Python you have got various modules and libraries to help you out with plotting and all this. In C, it's generally not the case, so I need to use external tools. Remember, these are system calls, so be very careful while writing C in this manner. This is not at all a safely written C code. Okay, this is just for made for understanding how a DFS and BFS algorithm will particularly work. So that's where this video ends. Goodbye, tata, bye bye.